In the 5th century BC, the Greek philosopher Democritus suggested that everything was composed of particles. He said that these particles could only be divided a certain amount of times until you cannot divide it any further. Democritus called this final particle atomos, which is Greek for indivisible. In 1794, John Dalton was elected a member of the Manchester Literary and Philosophical Society. One of his significant contributions to science was his research into colour blindness. He recognised that it must have been hereditary, as he and his brother were both colourblind. This research was so broadly recognised that Daltonism became a common term for the condition. Dalton also contributed to atomic knowledge, as in the early 1800s, Dalton built on Democritus's ideas about atomic theory. He had 4 main predictions about atoms. Atoms are tiny particles that make up elements. Atoms cannot be divided. All atoms of a given element are the same. Atoms of one element are different from those of every other element. Dalton also used his own symbols to devise the first table of atomic masses. Most of Dalton's predictions about atoms still hold true today. J.J. Thomson, who was born in Manchester in 1856, contributed to atomic theory between the years of 1897 and 1902, when he discovered the electron. At this time, cathode rays had recently been discovered, but no one knew what they were. Thomson discovered that cathode rays were a stream of particles. Each of these particles had a negative charge, they could be deflected by a magnet and an electric field, and they all had a very small mass. Cathode rays were actually electrons. Thomson suggested that they must have come from within the atoms of the electrodes, disproving the popular idea that atoms cannot be split any further. Thomson then went on to develop a model of an atom, where there was a sea of positive charge, which contained negative electrons. In Thomson's atom, the overall negative charge is the same as the overall positive charge, therefore the atom would be neutral. This model became known as the plum pudding model. Ernest Rutherford moved to the Victoria University of Manchester in 1907. It was here where he proposed the nuclear atom. Alongside Hans Geiger and Ernest Marsden, he carried out an experiment where he directed alpha particles at a thin sheet of gold foil. Rutherford said that if the plum pudding model was correct, then hardly any alpha particles would be deflected. The findings were opposite, as they found that a small percentage of the particles were deflected at large angles and very few particles were deflected back towards the source. From these results, Rutherford suggested that an atom's positive charge must be concentrated into a volume much smaller than the actual atom itself. In 1911, he proposed the nuclear atom as we know it today. The positive charge of an atom and most of its mass are concentrated in a nucleus at the centre of the atom. Negative electrons orbit this nucleus. Most of an atom's volume would be in the space between the nucleus and the electrons. The overall positive and negative charges must balance. After graduating from Oxford in 1910, Henry Moseley became a demonstrator in physics at the University of Manchester under the supervision of Ernest Rutherford. Moseley's experiments into X-ray spectroscopy determined the atomic number of the elements, allowing them to be put into their correct order due to these numbers, rather than in order of atomic mass as they were in Dmitri Mendeleev's periodic table. After Moseley's work, the elements could then be placed in the correct order in the periodic table as we see them today.